Hello, good morning, and I'm going to review today 1990 AMC8. Okay, as I told before, the problems in AMC is getting increasingly difficult year over year. So let's see how this one goes. The numbers on the faces of this cube are consecutive whole numbers. The sum of two numbers on each of the three pairs of opposite faces are equal. The sum of the six numbers of this cube. So they want the total of all the numbers. So I'm going to say here, so I know three numbers, right? So I have 11, I have 14, and I have 15. Now, what could be the possibility of the remaining numbers which can, add together? I'm just going to say, if I say 11, if I make this 11, 12, 13, 14, 15, and 16, right? This could be a possibility because 11 and 16 is the same number, 12 and 15 same number, 13 and 14 same number. This is a possibility. Okay, so in this case 15 has to have 12 opposite to it, 14 has to have 13 opposite to it, and 16 can have 11 opposite to it, right? This is what it should be. So we just have to total up these numbers and that's going to give us our answer. And in this case, the answer option is E81. Now there could have been another possibility here. So this could also have been 10, 11, 12, 13, 14, 15. This also could have been. So in this case, 10 and 15 will make the same number. This will make the same number. This will make the same number. But this possibility is not possible. Tell me why. Because for this possibility to be true, 11 and 14 needs to be opposite to each other, which is not. So this possibility doesn't work. Okay, that is why only this possibility works. So your answer option is E81. Going to the next question. There are 24 four-digit numbers that use each of the four digits 2, 5, 7, and 4 exactly once. Listed in numerical order from smallest to largest, the number in the 17th position in the list is. See, again, we are getting more and more tricky questions. So, but not difficult. We have a four-digit number. Okay. Now, we are going to list the numbers in alphabetical order. That's what it says, right? And we are going to have only these four digits and they are unique in the number. Okay. So, uh, first possibility is a number starting with 2 we can have, okay, six such numbers. Am I correct? So we can have 2574 and then 2745, 2457, and then you jumble, but 2 coming here we can have 6 possibilities. Okay, because I'm going to arrange them in numerical order, that's why I'm putting 2 first, then I'm going to put 5. Okay, and in this case I am going to say this also is going to have 6 possibilities. Now I'm going to take 7. Now see, 6 plus 6 I have 12. 7 will also have 6 possibilities. So we want the fifth number of the 7. That will be my 17th position. Right? So I want the fifth number of which starts with 7. So let's try this. So I'm going to put 7 here and I'm going to put the remaining in ascending order. Right? So I'm going to say the first number of 7 will be 7, 2, 4, 5. Okay, then I'll have 7, 4, 2, 5. Then I'll have 7. Now before this I'm going to have 7, 2, 5, 4. Correct? Then I have 7, 4, 2, 5. Then I'll have 7, 5. No, 7, 4, 5, 2. This is the fourth. Now the fifth number will be 7, 5, 4. The last number will be 7542. But we want this number, right? This is going to be our 17th. 12, 13, 14, 15, 16, 17. So this is my answer. 7524. Okay. Going to question number 13. One proposal for new postage rates for a stamp was 30 cents for the first ounce and 22 cents for each additional ounce or the fraction of an ounce. Postage for a letter weighing 4.5 ounces. So in 4.5 ounces, the first ounce is going to cost 30 cents. Okay. Then the remaining 3.5, which is nothing but 4, because they said fraction of an ounce. So this 3.5 will actually become 4 into 22 cents, right? So 22. So this will be 30 plus 88, which will be 118 or $1.18. Okay. Option C. Going to question 14. A bag contains only blue balls and green balls. There are 6 blue balls. Okay. If the probability of drawing a blue ball at random from this bag is 1 by 4. Okay. So if the probability of drawing a blue ball is 1 by 4, then the total number of balls in the bag will be 6 into 4 is equal to 24. Then the number of green balls. So 24 minus 6 is equal to 18, which will be green. So we have 18 green balls, which is answer option B. Going to the next question. The area of this figure is 100 centimeter square, its perimeter. So this total is 100 centimeter square, right? So each square is 25, correct? And this is 25, this will be 5, 5. So how many 5s do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 into 5. That will be 50. Answer option E. Going to next question. 1990 minus 1980 plus 1970 minus 1960. Okay. So uh, each double term, each two terms is giving you a value of 10, right? So this is giving you a value of 10, this is giving you 10. So how many such 10s are there? First we need to find out. So how do we do that? First we'll find the number of terms in this arithmetic progression. So I'm just going to forget about all the what do you call signs. Okay, I'm just going to take an arithmetic progression which starts from 10 and goes till 190 and find out how many 1990 and find out how many terms are there in that. Okay, so we know that to find uh, in an arithmetic progression we have this formula, right? So which is an, which is the last term, is equal to a plus n minus 1 into d, right? So an here will become 1990. I'm going to take that as the last term, and a here will become the first term, which is 10, and we have here n minus 1. We have to find n, right? We have to find the number of terms. The common difference I'm going to take as again 10. Okay, so I'm not looking at the signs, that's why I'm taking the common this one as 10. Okay, so if I'm going to solve this, I'm going to take 10 plus 10n minus 10, so minus 10. So this and this cancelled, so I'm going to get n as 199. So I know that there are 199 terms. Okay, now you see every second term, okay, sorry, every two terms together makes 10, but I have an odd number of terms here. I have 199 terms, so the last number is going to be left out. Okay, this number is going to be left out. So let's see how many tens we can make here. So every two numbers is a 10. So I'm going to keep the last number separate. I'm going to say 198 by 2. That is equal to 99 into 10. So I get 990. Total of all the first 198 numbers gives me 990, and this 10 which is left out, I'm going to add it now. So this is going to be 1000, right? So this 1000 is my answer. Answer D, 1000. Going to the next question. A concrete sidewalk is to be 3 feet wide. Okay, so 3 feet wide, 60 feet long, and 3 inches thick. 3 inches thick. Okay, so it's going to be something like this. Okay, how many cubic yards of concrete must a contractor order for the sidewalk if the concrete must be ordered in a whole number of cubic yards? Okay, so cubic yards. So we want all measurement in yards. Then only we can have the answer in cubic yards. We have to find the volume of this, right? It's a cuboid. We need to, so it's a, yeah, uh, we need to find the volume of this cuboid. So uh, we are going to say everything should be in yards. So let me just convert. So 3 feet will make 1 yard, right? And then 60 feet is going to make 20 yards. And then we have 3 inches. This is equal to, so in a feet, there are 12 inches, correct? So in 1 yard, there will be 1 by, if it's 3 inches, it will be 1 by 4th of an yard, correct? So now I'm going to say volume is equal to length into breadth into height. So that is equal to 1 into 20 into 1 by 4. Am I doing it correctly? Somewhere I'm mistaken. This will give you 5. Is that the answer? Let me check. Yeah, so looks like I made a calculation error here. So it's 3 inches, right? So this 3 feet is 1 yard. So I have only 3 inches. So this is not 1 by 4. This is 1 by 12, right? That's an error I made. So let's correct it. Okay, because if it is 3 inches for 1 yard, it will be 1 by 4. But we have 3 yards, right? So it's 1 by 12 of a yard. So here you are going to get 1 by 12. Correct? So this one is we are going to get 1 point something 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 as the answer. So your answer option is A. It will be 1 point xxx. So it will be A, your answer option, because we need only close to 1 cubic yard. So for that we are going to order a whole cubic yard of 2 cubic yards. Okay. Going to the next question. Each corner of a rectangular prism is cut off. Okay, 2 of the 8 cuts are shown. How many edges does the new figure have? Now, this is an edge. This is an edge. Okay, and this is a vertex. What do we call this? We call this a vertex. So, this is an edge and this is a vertex. Now, how many existing edges does this figure already have? Right? So, I have 4. Then we have 4, 5, 6, 7, 4 plus 4, 8, 9, 10, 11, 12. So, initially we have edges as 12. We have to find the edges of the new figure, and each of the vertex, so I have 8 vertex, each of the vertex is going to add 3 more edges. You see this? 1, 2, 3. The existing edges are going to remain, but each vertex is going to add 3 more edges. I have 8 vertices, right? So 8 into 3 is equal to 24. New edges are added. So totally I'm going to have 36 edges. Okay, so here's your answer, C.